Okay, so the next question is you want to find the equation of a line which is parallel to this line, parallel to 3x minus 4y plus 2 is equal to 0, and passes through the point passing through negative 2 comma 3, negative 2 comma 3. So since the line is parallel to this line, if you find basically the slope of this line, you can use that slope to construct a new line. So basically you have 3x minus 4y plus 2 is equal to 0. And if you remember, of course I can move these terms around. For example, I can write negative 4y is equal to negative 3x minus 2, and then I can write, for example, 4y is equal to 3x plus 2, and then divide by 4y is equal to 3/4 x plus 1/2, for example. And then of course then basically the slope of the line is 3/4, and since then the line that I'm looking for is also parallel to this line, the slope of that line is going to be also is going to be 3/4 of the other line, and then it goes through this point as well. So then you would be able to use y minus y1 is equal to m times x minus x1 and write the equation of the line, meaning that y minus 3 is equal to 3/4 times x minus x1, which is equal to plus 2. So y minus 3 is equal to 3/4 x, and that is 6/4. 6/4 is equal to 3/2 plus 3/2. So then you can write basically negative 3/4 x, negative 3/4 x plus y minus 3 minus 3/2 is equal to 0. And so if you add these two numbers together, this is a negative 3, this is negative 3/2. So that's 4.5, 4.5, negative 4.5. So negative 4.5 is 9 divided by 2. So that's negative 9/2. And there you have basically negative 3/4 x plus y is equal to 0. Then you can basically multiply by a factor of 4 to get rid of this 4 and 2. So you get negative 3x plus 4 times y, and 4 divided by 2 is equal to 2, 2 times 1 is equal to 18, is equal to 0. And then you can multiply by negative 1, you'll get 3x minus 4y plus 18 is equal to 0. So that is the equation of the line. So question number 7 is 3x minus 4y plus 18 is equal to 0. Now I don't remember what I wanted to show you here. Oh yes, I wanted to show you basically in order to get the slope of this line, I had to do all of this this calculation over here to get to this slope. But if you remember, we said that basically we said that when we wrote the slope intercept form of the equation of the line, we said y is equal to mx plus c, over here m was equal to, basically in this equation over here, ax plus by plus c is equal to 0. In this equation, m is the same thing as negative a to b. Negative a to b. That means that if this is your line, negative a to b over here is negative 3 to negative 4. M is equal to negative 3 to negative 4, which is equal to 3/4. And that's exactly this slope over here. That means that if you can remember these little things, they will help you a lot in doing different things. They will save you a lot of time. But on the other hand, it's not, it's not that it's not possible to remember them, but it takes some time for them to just fall into place inside your mind. So you have to keep working with them for a while, and then after a while, automatically they will just slide into place. And there is no need to basically try to memorize them, because unless you're writing an exam or something, in which case you need to, for example, you have to basically memorize them. But if you don't memorize them, you can just keep all of these formulas and everything in notebook, and then just do mathematics for, whatever it is that you do. Most probably you do mathematics every day, and then every day you have to go back to all of your notes and the formulas and everything. And so after a while, automatically you will remember all of them. But it's not, you cannot basically, you cannot expect to remember these, for example, after 2 days or after 3 days. It doesn't work like that. It takes some time, basically. It does need some time. Okay, so that is basically that. Alright, so the next question that we have here is question number 8. It says find the equation of the line perpendicular to this line and having x-intercept 3. So if your line is perpendicular to basically x minus 7y plus 5 is equal to 0. So if I calculate the slope of this line, so you know that m is equal to negative a by b, meaning that just make sure that negative a by b. So basically that means that the slope of this line is equal to negative a, which is equal to 1 over b, which is equal to negative 7, which is equal to 1/7. Now I call this m1, and I call the slope of the line that you want to we want to find, I want that m2. That is the slope of the required line. Now, since the two lines are perpendicular, I can write m1 times m2 is equal to negative 1. Or I can write basically 1/7 times m2 is equal to negative 1, which means that m2 is equal to negative 1 over 1/7, which is equal to negative 7. Negative 1 over 1/7 is equal to negative 7. So you can say that m2 is equal to negative 7. That is the slope of your line. And also this line has an x-intercept, of 3, meaning that when a line has an x-intercept, that means that it cuts the x-axis at that point. So 1, 2, and 3, and the line basically, now wherever it goes I don't know, but it goes through the x-axis at this point. That means that this point is a point on the line, and the coordinates of this point is 3, 0. So that means that the point 3, 0 is a point on the line, and the slope of the line is -7. So y minus y1 is equal to m times x minus x1. So y minus 0 is equal to -7 times x minus 3. And so y is equal to -7x plus 21. So you can change it to the general form, or you can keep it this way, but that is the equation of the line. Number 8, y plus 7x is equal to 21. That is the correct answer. Now the next question that we have is question number 9. Question number 9. So find angles between these two lines. So basically you have two lines over here. Square root of 3 times x plus y is equal to 1, and x plus square root of 3y is equal to 1. You have these two lines, and you want to find the angle between these two lines. So basically we said that the angle between two lines is basically equal to tan theta. The angle basically, if I were to do a diagram, if you have, for example, let's say that this line over here and this line over here, and they intersect at this point, then you will have this acute angle, and then you will have this obtuse angle. Now if I call this acute angle theta, the relationship between, and for example, I don't know, you could, for example, take the slope of this line as for example m1, you can take the slope of this line as m2, and there is a relationship between tan, basically the tan of this angle and these two quantities, meaning that you can write tan of theta is equal to the absolute value of, I have forgotten the formula. I cannot write here anymore. Okay, so the formula is was basically, let me find the formula. Okay, so the formula was m2 minus m1. So we said that tan of theta is equal to basically the absolute value of m2 minus m1, 1 plus m2 minus m1, 1 plus m1, and m1 times m2. So, and so what was the question over here now? My mind is a little bit jumpy right now. You want to find the angles between these two lines, so you need to basically have these two values, m1 and m2. So I write this formula down here. Tan of theta is equal to basically m2 minus m1, 1 plus basically m1 m2. Okay, so that is basically the formula. Now what I need to do is at first find the slopes of these two lines. So call this, for example, 1, call this 2. Basically 1 gives me the slope of this line. You can simply write it as negative a by b. You know that m is equal to negative a by b. If you have an equation if you have the general equation of a line, ax plus by plus c is equal to 0, if that's the case, then the slope of the line is negative a over b. So you don't have to really do much calculation here. You can simply write over here m1 is equal to negative a by b, so that's negative square root of 3. And basically m2 over here is again negative a by b, so that's negative 1 by square root of 3. Negative 1 by square root of 3. So now I have these two values. I have to put it in this formula to get my theta. So I can write tan of theta. Tan of theta is equal to basically m2 minus m1. So negative 1 over square root of 3 minus negative square root of 3, that becomes plus the square root of 3, and 1 plus basically these two multiplied together. So you have negative square root of 3 times negative 1 over square root of 3. If you multiply these together, take the absolute value of the whole thing, what you will get is, first of all, these two will cancel out. These two will cancel out. And so you have 1 plus 1 is equal to 2. Your denominator becomes 2. And the numerator over here becomes basically, I take the LCM as square root of 3. So that's negative 1 plus the square root of 3 times square root of 3 is equal to 3. And 3 minus 1 is equal to 2. Now I have a 2 over here as well, and so basically 3 minus 1 is equal to 2 over square root of 3, and divide the whole thing by 2, which is the same thing as 2 over square root of 3 times 1 by 2, and you can cancel these two out. You'll get 1 over square root of 3. So, and this comes out of the absolute value function, becomes 1 over square root of 3. Doesn't change really. So, tan of theta is equal to 1 over square root of 3. And of course, I am looking for the acute angle over here, meaning that you need to be aware of the fact that there are actually two angles over here, meaning that there is this angle which I can call, for example, phi, and as you can see, theta plus phi is equal to 180 degrees. And then this angle over here is the same as phi, and this angle over here is the same as theta, meaning that they are equal because they are vertically opposite angles. So if you find this angle, based on this angle, of course, using this equation you can find this angle, and the whole problem is basically solved, and then that's basically the whole story. Now so theta over here, so long story short, what I meant to say was that theta is an acute angle, meaning that when you say tan of theta is equal to 1 over square root of 3, this angle the tan of this angle can be related, the tan ratio of this basically this tan ratio related to this angle could be related to any angle. It could be even larger than 360 degrees. But you need to basically pick the very first solution, which is in the first quadrant, and I think it's 30 degrees or 60 degrees. We will see. So you know that sine 30 degrees is equal to 1 by 2, and cos 30 degrees is equal to square root of 3 by 2. That means that tan of 30 degrees is equal to this divided by this, which is 1 divided by 2 over square root of 3 by 2. 2 and 2 you can cancel out, and you get 1 over square root of 3. So that means that your theta, you can take it as 30 degrees. You can take it as 30 degrees. And so phi, you can take it as 150 degrees, because both of them together then make a 180 degree angle. And that's basically all that we needed to calculate here. So let me see. Question number 9. 30 degrees and 150 degrees. Okay, so the next question is question number 10. Okay, so the next question is question number 10, which is the line through these 2 points intersect the line at right angle. Find the value of h. So basically we have a line that goes through these 2 points, h, 3 and h, 3 and 4, 1. 4, 1. And this line intersects the line basically 7x minus 9y minus 19 is equal to 0 at right angle. So what that means is that the line that goes through these 2 points is actually perpendicular to this line. If you have a line, and if you have another line that intersects this line at right angle, that means that if you have this m1 and m2, m1 times m2 is equal to -1, or that means that if this is, for example, L1 and this is L2, L1 is perpendicular to L2. So that means that the line that goes through these 2 points is perpendicular to this line. So what we can do is that I can find the slope of this line, which is equal to m is equal to negative a by b, which is equal to -7 by -9, which is equal to 7/9. The slope of this line is 7/9. And that means that basically if I take this as, for example, m2, then I can write m1 times m2 is equal to -1. And so m1 times m2, which is 7/9, is equal to -1. And that means that basically m1 is equal to -1 over 7/9, which is equal to -9/7. -9/7. That means that m1 is equal to -9/7. So now, since that is the case, so now you have a line that goes through, for example, this point 4, 1, and the slope of the line m of 1 is equal to -9/7. So you can simply calculate find the equation of the line, which is x minus x1 is equal to m times, I'm sorry, y minus y1. Y minus y1 is equal to m times x minus x1. So y minus 1 is equal to -9/7 times x minus 4. So y minus 1 is equal to -9/7 x plus 36/7 plus 36/7. So that means that basically 9/7 positive 9/7 x plus y minus 1 minus 36/7 is equal to 0. Now -1 minus 36/7 is equal to 7 over here, so that's -7, and minus 36 plus 7 is equal to 43, so that's -43/7. So you can write basically 9/7 x plus y minus 43/7 is equal to 0. And if I multiply by a 7, I'll get 9x plus 7y minus 43 is equal to 0. That is the equation of the line. That is the equation of this line over here. Now you want to find the value of h. So basically you have a point over here h comma 3. You have a point over here h comma 3, and you know that it is located on this line, 9x plus 7y minus 43 is equal to 0. So your y is basically 3, so 9x plus 7 times 3 minus 43 is equal to 0. 9x plus 21 minus 43 is equal to 0. And 9x 43 minus 21 is equal to 22. 43 minus 21 is equal to 222. That's -22 is equal to 0. 9x is equal to positive 22x is equal to 22/9. And that means that this point, that means that h is actually 22/9. That is the value of h. I'm not really sure if the answer is right. Number 10, 22/9. The answer is correct. Number 11, you want to prove that the line through the point x1, y1 and parallel to the line ax plus by plus c is equal to 0 is this line over here. So you have a line through the point x1 comma y1 through this point, and parallel to basically ax plus by plus c is equal to 0. Parallel to this line is basically, you wanted to show that this line is basically is a times x minus x1 plus b times y minus y1 is equal to 0. Okay, so if your line goes through this point, if this is one point on your line, and your line is basically has the same slope, meaning if it's parallel has the same slope as this line, then you can basically write y minus y1 is equal to m times x minus x1, and x1 y1 is one point on the line, and of course your basically my slope over here is negative a to b. So this line will have the same slope. So I can write y minus y1 is equal to negative a to b. I'm writing negative a to b based on the calculations that we did before. We know that if you have a line over like this, the slope is negative a by b. So negative a by b times x minus x1. And now if I multiply by a b, I will get b times basically y minus y1 is equal to negative a times x minus x1. And so I can write a times x minus x1 plus b times y minus y1 is equal to 0, which is basically what we had over here. So that means that if you have a line that goes through this point x1 y1, and if it is parallel to this line, then the equation of the line becomes a times x minus x1 plus b times y minus y1 is equal to 0. Question number 12 is two lines passing through the point 2, 3 intersect each other at an angle of 60 degrees. So there is a point over here. There is a point over here 2, 3. And two lines are passing through this point. Two lines passing through the point 2, 3 intersect each other at an angle of 60 degrees. So that means that, suppose that, for example, just an hypothetical situation, the line is going to be, for example, one line is like this, and suppose that this is a 90 degree angle, 90, 15, 30, 45, 60, and this is a 60 degree angle, for example, and this angle theta is equal to 60 degrees. Okay, so these two lines are basically in this configuration. Of course, we don't really know basically the exact orientation of these two lines, meaning that the two lines could be in any other way, meaning that you could just move these around, of course together in such a way that this angle is not disturbed, but then meaning that the angle between the two lines is going to remain 60 degrees, but we don't really know if this is the exact orientation of the two lines put together. There could be any other orientation or any other direction. If the slope of one line is 2, so if the slope of one of these lines is 2, so we don't know which one, but I'm going to define two slopes, m1 and m2, and I'm going to just arbitrarily say that, for example, m1 is equal to 2. Find the equation of the other line. You want, basically, if the slope of one line is 2, then you want to find the equation of the other line. Okay, so now if using, it's actually very easy to find basically the equation of the line, because we said that tan of theta, is equal to the absolute value of, if I'm not mistaken, m2 minus m1, m2 minus m1, m2 minus m1, 1 plus m1, m2. Okay, so this is the equation, this is the formula that we use to find the angle between two lines. So now we know that this angle theta is equal to 60 degrees. So I write tan of 60 degrees is equal to the absolute value of, for example, m2, which is what I want to find, m2 minus 2 over 1 plus, basically m1 is 2 times m2. And now tan of 60 degrees was, I suppose, 1 over square root of 3. I should write these down somewhere. I don't actually have no notes whatsoever in mathematics. I have only some notes in trigonometry. Otherwise, in other places, I just simply usually use logic in order to figure things out, and my memory is not that great, really, most of the time. Or I could say I don't usually try to memorize anything, so I don't have any formulas in my mind. But I think I should start writing down a couple of things and putting a notebook or a couple of notes together. So tan of 60 degrees is sine 60 degrees over cos 60 degrees, which is equal to square root of 3 by 2 over 1 by 2, which is equal to square root of 3, is square root of 3. So how was it that we got 1 over square root of 3 the last time? 10 pi by 3. Pi by 3. Square root of 3. That's right. Okay, so this is then equal to square root of 3. This is equal to square root of 3 is equal to basically the absolute value of m2 minus 2, 1 plus 2 times m2, and so now you need to solve for m2 in this absolute value equation. So what you can do is that you need to write basically m2 minus 2 over 1 plus 2 times m2 is equal to plus or minus square root of 3. That means that That means that basically either m2 minus 2 over 1 plus 2 times m2 is equal to positive square root of 3, or you could say that m2 minus 2 over 1 plus 2 times m2 is equal to negative square root of 3. So in this case, if I call this, for example, equation, I haven't called anything here. So I call this equation number 1, and I call this equation number 2. And so equation number 1 is going to give me basically m2 minus 2 is equal to square root of 3 plus 2 times the square root of 3 m2. And so I can write this as m2 minus 2 times the square root of 3 m2 minus 2 times the square root of 2 times square root of 3 times m2 is equal to square root of 3 plus 2. Square root of 3 plus 2. So if I take m2 out, I'll get 1 minus 2 times the square root of 3. 1 minus 2 times square root of 3 is equal to square root of 3 plus 2. And so m2 is equal to square root of 3 plus 2 over 1 minus 2 times square root of 3. That is one value for m2. And of course m2 can have two values, because you can keep moving your line and you would get basically I think that they would be the same results, meaning that suppose that, for example, your point is somewhere over here, and the angle between this is one of the lines, and let's say that, for example, one of these lines, let's say that the slope of this line is 2. M is equal to 2. Now, in order to get some line that makes an angle of 60 degrees with this line, you can go in this direction, for example, assuming that this angle is a 60-degree angle, and you can do this. Otherwise, you can do this as well. You can do this as well. And so you get two lines over here, meaning that this is also a 60-degree angle. So I suppose you will get basically two separate lines. So what that means is that now m2 is equal to square root of 3 plus 2 over 1 minus 2 times square root of 3, and equation number 2 is going to give me basically m2 minus 2. m2 minus 2 is equal to negative square root of 3 times 1 is negative square root of 3 minus 2 times square root of 3 times m2. And so m2 plus 2 times square root of 3 times m2 is equal to negative square root of 3 plus 2. And so if I take an m2 out here, I will get 1 plus 2 times the square root of 3 is equal to negative square root of 3 plus 2. Or I can write this as m2 is equal m2 times 1 plus 2 times square root of 3 is equal to 2 minus the square root of 3. This way is better. And m2 is equal to basically 2 minus the square root of 3 over 1 plus 2 times the square root of 3. And that is another value for m2. So now we have a line whose slope is either this slope or this slope, and one point on the line is 2, 3, because this 2, 3 is basically on both the lines. So 2, 3 is one point on this line, and if I take basically this slope over here, I will get y minus y1 is equal to m times x minus x1. So y minus basically 3 is equal to this slope, which is square root of 3 plus 2 over 1 minus 2 times the square root of 3 times x minus 2 times x minus 2. And you don't really need to simplify this. You can leave it as it is. And then the second line, the line goes through this point, and this is the slope of the line. So again, y minus y1 is equal to m times x minus x1. So then you can write y minus 3 is equal to 2 minus square root of 3 over 1 plus 2 times the square root of 3 times x minus 2. And this is another equation for this line, and that is basically that. So you get two equations for this line. So that was question number 12. I suppose our answer is not wrong, but it doesn't really matter if, it does really matter if your answer is wrong, but I suppose my answer is not wrong, but I have no way of verifying it. And I'm like 99.99999% sure that the answer is right. So we can move to the question number 13. Question number 13. Okay. Okay, so question number 13. Question number 13 is find the equation of the right bisector of the line segment joining the points 3, 4 and negative 1, 2. So you have these 2 points, negative 1, 2 and 3, 4, and you want to find the equation of the right bisector of the line segment joining these 2 points. Now the right bisector of this line segment, I don't really, well, I would imagine that if this is for example, the line segment, of course the bisector would bisect the line, meaning that it basically divides the line into exactly 2 equal basically line segments. And I suppose if it's supposed to be the right bisector, that's supposed to be at an angle of 90 degrees. So that is the same thing as there is a name for this in there is a name for this in geometry called the perpendicular bisector. They call it the perpendicular bisector of this line segment. Perpendicular bisector. So perpendicular, of course, means that they are perpendicular 90-degree angle they make. And bisector means that this line segment is equal to this line segment, meaning that this point is the exact midpoint of this line segment. So that's pretty simple. Now, so all I need to do is find basically the so as you can see, this line goes through the midpoint of these 2 points, and if I take the slope of this m1 and the slope of this line m2, I know that since these two are perpendicular, I know that m1 times m2 is equal to -1. And if I find the midpoint of these 2 points, then of course that point is going to be 1 point on this line over here. So then the midpoint of basically, for example, let's call it AB, of AB is equal to basically -1. It's basically the midpoint formula, as you know. The midpoint, as you know, is equal to basically x1 plus x2 over 2 and y1 plus y2 over 2. And this is basically a case of that, a special case of that I don't know what to call it, that theorem that we talked about, that if you have a line segment over here, let's say that you have this line segment over here, and if there is a point on this line, that divides this line in the ratio, internally in the ratio m to n, then the coordinates of this point, is basically meaning that you can write x1 comma y1 of this point is going to be equal to m times x1, if I'm not wrong, 26, is going to be m times x2 plus n times x1 over m plus n. This is the x coordinate, and the y coordinate of this point is going to be m times y2 plus n times y1 over m plus n. Of course, there is something about choosing, about choosing the ratio over here. Basically, what, for example, if you're given some information that, for example, a point divides a line segment internally in the ratio 2 to 3, you need to know that, and you know that your ratio over here is m to n. So you need to know whether you should, in that particular situation, you should take this as, you should basically take 2 to 3 as m to n or as n to m. Depending on that situation and depending on what you want to do with that point, you need to choose one of these two, because if you choose the wrong one, then the point is going to be just moved around. Meaning that, for example, if the ratio, if this point, for example, is supposed to divide this line segment internally in the ratio, for example, 1 to 3, for example, you need to basically, for example, take your m as 1 and your n as 3, and then of course you need to be careful about these two endpoints. So it's kind of like an art, but once you work with this formula for a little bit, at least solve 5, 6, 7, 10 exercises using this formula, you will get the hang of it. Otherwise, it keeps giving you different results, maybe something that you don't really expect get from the formula. But otherwise, other than that, if you know how to use it, it will give you, of course, consistent results. Now, anyway, what's important here now is that now we said that basically basically this point over here, the coordinates of this point, if it divides this line in the ratio m to n, we said that basically m times x2, for example, plus n times x1 over, for example, m plus n, and this is the x coordinate, and the y coordinate of the point is going to, of this point is going to be, for example, m times y2 plus n times y1 over m plus n. So now if m is equal to n, meaning that if some point is the midpoint of a line segment, then of course it divides that line segment in turn in the ratio 1 to 1, meaning that your m to n is equal to 1 to 1. And so as you can see over here, m plus n is equal to 1 plus 1, which is equal to 2, and then of course m is equal to 1, n is equal to 1, so then you will simply get x1 plus x2 over 2 and y1 plus y2 over 2, and that becomes this formula, which they have called the midpoint formula. That's basically why I said it's a special case of this basically formula over here. Okay. Now if you now basically what we need is that we need to calculate the midpoint of AB, and we do have basically these points over here. So x1 plus x2 is negative 1 plus 3 over 2 and 2 plus 4 over 2. So this is equal to basically 3 minus 1 is equal to 2, 2 over 2 is equal to 1, 6 over 2 is equal to 3, 1 comma 3. So 1 comma 3 is this point over here, and of course you can of course calculate the slope of this line segment, meaning that the slope of AB, and of course I can call this, for example, line L. The slope of AB, which is a line segment, is equal to basically y2 minus y1 over x2 minus x1, which is equal to basically 4 minus 2 over 3 plus 1, which is equal to 2 over 4, which is equal to 1 over 2. So that means that m1 is equal to 1 over 2. Now, what remains here is that I can write m1 times m2. m1 times m2 is equal to negative 1 because these are perpendicular. So then m1 is equal to 1/2 times m2 is equal to negative 1. So m2 is equal to negative 1 over 1 by 2, which is equal to negative 2. So this is equal to negative 2. So now I know the slope of this line, m is equal to negative 2, and one point on the line is 1 comma 3. So I can simply write y minus y1 is equal to m times x minus x1, which means that y minus 3 is equal to negative 2 times x minus 1. Y minus 3 is equal to negative 2x plus 2, and y is equal to negative 2x plus 5. And that is the equation of this line over here. Y is equal to negative 2x plus 5. So that was question number I don't know where I was. Only 6, I suppose. That was question number 13, I suppose. Question number 13. Okay, so question number 13 is 2x plus y. 2x plus y is equal to 5. So this is actually correct. Okay, so I'm going to end this video here, and then we have question number 14 through 18 that we will do in the next video. See you in the next video.